As time went on, the necessity for water increased, and the creation of terracotta pipes, which can be seen in this picture, they were handmade, were used. They were used in many ancient civilizations. The Minoans on the island of Crete were credited for having the first pipes around like 3,500 years ago. So just goes to show how long ago we've been thinking about transporting massive amounts of water. So although these pipes are not pressurized, it did meet the main purpose of delivering water to a population. So even the ancient Romans used lead piping, as we can see in this picture, for transporting water. Now, this is a lead line in an ancient facility. So we have been using lead lines for centuries and centuries. This is an example of how timber was at one point used as a water main. So this was removed from Wall Street in August 18th of 2006. The state of this, the state of this water main looks relatively, pretty good condition. I'm pretty sure there are still some wooden pipeline structures in the distribution today. So as time went on, and also in certain areas, access to water would have been more difficult for the high terrain regions. In this situation, you can't have water flow uphill without the use of pumping equipment, correct? So one way to get around this is to manipulate topography to your advantage. And as we can see here, the landscape goes from a higher elevation to a lower elevation, and you have groundwater also following that same path underneath. So what they did back in the day is they would tunnel back into the hill to intercept the water table with water following down the path of least resistance. The water will start to flow through the dugout canal if it's at a slope. So they figured out in ancient times and started to dig into the landscape to access the water table and get it to flow down a gradient. So even a slight gradient will get that water to flow in the direction desired. We can see they can lower material to fortify the tunnel and to remove dirt with ease. So, this is another method that was used by ancient civilizations to access water. And as the progression continued with aqueduct systems, that was perfected by the Romans in around 312 BC, and built 16 kilometers of aqueducts for their Roman citizens. With their extensive knowledge of concrete and structure building skills. Now, essentially, what was realized by the Romans was that all you needed was a water source, such as a lake, stream, at a higher elevation. And when you give it a direct path to flow at a certain gradient, it can provide cities and towns with fresh water. So as we can see here, we have our intake structure, the Roman aqueduct, and then it goes through a channel, and then reaches the aqueduct bridges, which water flows across. Notice that it's all at a gradient, which allows the water to flow and give cities their needed water. Now, in modern times, we still use the same technology of creating aqueducts to supply to a treatment plant and thereafter a city. But also the reverse is now possible. If the cities are at a higher elevation than the water source, we can now use pumping equipment to pump that water against the gradient up to a city, as we can see here. So this picture is an aqueduct system that was used in ancient times by the Romans, and it's essentially a water bridge for flowing water to be carried from one location to another. The aqueduct itself had to be maintained at a certain gradient so that water can flow down that sloped system. Here, another view of an aqueduct with a gradient, I believe also in South America. So the Romans were not the only civilization that used aqueducts. This aqueduct is flowing constantly still after centuries of use, and it's located in Mexico City. So this aqueduct was built by the Spanish using Roman techniques after their conquest of the Aztec Empire. The Aztecs themselves had built these aqueducts to provide water for their people. So, it just goes to show you how long these structures can last and continue providing water for the citizens. Now, the longest aqueduct built was Roman, and it spanned more than 50 miles. This aqueduct is, it's not the largest, but it's very long, and it is located in Mexico. Building these aqueduct systems required tremendous amounts of precision and skill to keep a gradient over a long distance for water to flow. And how they achieved this without modern tools is really impressive. Another type. So these are a little different kind of aqueducts. These are called puquios. These are from the pre-Inca civilization called the Nazca in Peru, South America. So these are underwater types of aqueducts. So the corkscrew funnels are used for access to the aqueduct. These are used to transport water also in an area where dry climate is common. This type of aqueduct is used to reduce the amount of water loss due to that evaporation from warmer climates. So as we can see, many of these little aqueducts are connected together via channels, right? Connected via one another through underground channels, and forms a flow of that water. And the thing that's pretty amazing about these puquios is that on windy days, the wind is channeled down that spiral, and then it creates a pushing motion to pump the water faster to a location. So as of the year 2000, there's still 43 of these aqueduct systems that are still functioning in Peru and still providing, water for irrigation purposes to the population. So again, pretty amazing. Here we see a storage facility in ancient Rome. The storage facility had pipes that, exiting the storage chamber at different elevations that would run out to different locations in Rome. Notice some of the brilliant colors from mineral deposits and bacteria slash algae. So as technology progressed, we found a way to actually lift water from a river source. In this picture, we can see that they're using the force of the river channeled through a small channel in a dam to create a greater pushing force, and therefore allowing the turning of the wheel, which would lift water up to a certain elevation for transportation. Now, the advantage of this is that you would now lift water higher, and therefore had the ability to transport water to further locations compared to if you just had to start at the water source, which was at a lower elevation. So one of the first pumps invented was by Archimedes. This pump was called the Archimedes screw pump and was originally designed to remove bilge water from the bottom of large boats. And realizing its true potential, you could pump water from different locations with ease through the use of manual labor by turning this handle here. So even that long ago. So the real game changer was the invention of the sliding vane pump. Oh, sorry. Actually, I got the wrong slide here. So this pump here in ancient Rome, it's an ancient Roman pump. It is known as the piston pump and worked on the principle of displacement. It contained two check valves, and two pistons that, when actuated, would force water out of the nozzle. Two people usually operated the pump, one on each end. When one would push down, it would suck up water into the chamber, and then when the other one would push up, it would exit that water through the nozzle on the top. So even that far ago, great inventions. Now, the real game changer was when the invention of the sliding vane pump and the gear pump. Now, this is what then allowed flowing water to be elevated for storage and for pressure purposes. So why do we build it? So with a constantly growing population, we're required to constantly supply fresh water. Even now in modern times, we have to find creative ways of supplying sufficient water to millions of people. Nowadays, getting water to people is not enough. We must also make water safe to drink through processes of chlorination, disinfection methods, so that we don't get sick and potentially, you could potentially die from certain types of infections. So the water we drink must also be aesthetically pleasing, meaning that the water is free of foul taste, color, odor, or else, we wouldn't want to drink it. So the start of regulation, this was kind of the start of drinking water regulations, and it can really be attributed to the Romans that established these first kinds of regulations of water quality. So when conquering new territories and trying to establish new provinces, the Romans had a designed group of individuals that evaluated new water sources for clarity, taste, and odor. They would also check the health of the surrounding population and analyze their water source against their own qualifications, which was clarity, taste, odor, to make sure that the drinking water met their expectations. So what is the driving force for regulation of water systems? And that is public health. Without access to water for bathing, cooking, crop irrigation, etc., a civilization would not be possible. Since clean water is needed to sustain a growing population that's consistently consuming water, and having the technology to disinfect this water and protect public health is the overall goal.